Hi, today I'll be presenting my deep learning assignment 2, which is developing a sequence generator model. So first of all, a table of contents is to have the overview, data pre-processing and loading, and developing a sequence generator models. Then lastly, we do like qualitative analysis to examine through human examine the how the sequence generator model can generate the text character by character, and lastly the conclusion. So we first going to define the problem statement. Problem statement is to build a sequences text generation model to mimic J.K. Rowling when writing Harry Potter, the Prisoner of Azkaban. So when using Harry Potter and Prisoner of Azkaban, right, we usually input data to the model, and we usually use of RNN uh, models to capture the sequential patterns of the text data. So you can see input output pairs. Okay, so the input and then you got output. So this output is actually one character by character, and then you get output until we can unfold the rest of the sequence. So we first do like data pre-processing and loading. So we set up Google Drive. We loaded using re.sub function to perform a regular expression substitution. Re is regular expression to replace sequences of new line characters or even remove the page number or the the slash. Okay, so remove uppercase, is upper, etc. Because of some of the things need to clean. So as a result, you can see the text is clean like this. So it doesn't have that things like hour, post, page number, and it's actually noise to the data. So now we're going to address the vanishing gradient problem. Very simple. We are doing LSTM models to mitigate the vanishing gradient problem. The RNN is actually facing the current neural networks facing. So we try and minimize like the way the way updates, so there be like more updates of the weights. Then we try and do the baseline model. Okay, baseline model start off with the custom embedding dimension of 50, maximum sequences or H train is 20, hidden layers. We try to have one hidden layer. We start very small with Adam, and then using model checkpoints to save the best way training. We actually didn't tune optimizer, and we didn't do optimizer. But first we will try to go in depth into only a few hyperparameters focus, which is custom embedding tuning. So we represent it using 100 to 500 embedding dimensions. So generally, the higher embeddings result in the greater validation accuracy, and higher embedding dimension results in more detailed representations on the dimensional space. So you see the validation accuracy increased by a lot for 500 embedding layers. You can see the qualitative analysis for 100 versus 500, right? You see 100 is quite repetitive, but 500 capture a bit more details of how you want to generate things. So the patterns are more clearer in the sense to the model. You can tune the learning rate, which learning rates are high learning rates are unsuitable as they are unstable to shift the accuracy too much at one go. Okay, so the LR of 0.001 is still the most stable learning rate. Now we tune the number of hidden layers. Okay, so using 4 hidden layers, right, we're actually able to deepen the model and lessen the overfitting, because our theory is that the more depth of the model, right, the more complexity you can capture of the Harry Potter data, which means it will be more accurate with 4 hidden layers. So you actually reach a very nice upward trend for most likely for the deeper models as well. And also we can a bit reduce the trend accuracy to so-called reduce overfitting. Then we can tune the sequence length. Okay, so I actually explored 2 sections of sequence length to much longer sequences for 100 was unsuitable. So we should take the highest value accuracy of testing of like 50, 60, or 100 the sequence lengths. We will tune later. But first I'll talk about temperature sampling. So temperature sampling is a way to sample highest probability of output words. Okay, so it's almost unique characters for the output layer of the model, and you can output the most predicted probability. And by introducing a high temperature, we are actually having more random uh, distribution of this distribution, and you can have more creative text this way. So we can observe temperature point of 0.5 actually is the most like readable text as well. So we continue the sequence length after we try to explore temperature. So we realized 20 or 30 characters long generated the best validation accuracy, and it generated the best coherence related to the input prompt. So we can conclude that the shorter sequence lengths result in less lengthy generated sentences, because the temperature the generated earlier actually has a very long sentence until the full stop. So lastly, we use perplexity as a measure to measure whatever we've generated. So perplexity is the way to measure surprise, how surprised the uh, model actually is, which means we use a pre-trained transformer called GPT-2 to try and understand the context and make sure it's whether is it surprising or not surprising. So lower values, lower score of complexity indicates less surprise. Okay, so okay, 50 is a little bit surprising. So I say even the more text that make more sense actually is more surprising, and the complexity is not too low either. Okay, so last we did a qualitative analysis to try evaluating the text qualitatively and realize that actually there's still text that do not flow. The stories of Harry Potter are still very choppy, and a lot of new lines which you could have cleaned them during the preprocessing. Basically, the new lines. This is the story that is generated based on input prompt of Hermione and Harry discovering a secret passage, etc. So to summarize, right, we actually had the custom embedding dimensions of 100 parameters being tuned, as well as 4 hidden layers, 128 nodes each, learning rate of 0.001, sequence length of 30, and a temperature around 0.3 0.5. It really depends on how creative you want the model to be. So the further improvements, you can explore more layers such as GRU or Conf1D layers or further regularize the model. Thank you.